Second. We are doing some more trig, I believe.
Okay. Is it stuff you can verbalize?
I believe so.
Okay.
So,
if you come across anything that you can't verbalize, like a graph that they're wanting you to interpret, I will put my email address on my screen so that you can take a picture and send it to me.
Okay.
And definitely don't send it to the email address on Digital Math Tutor. That can take like 20 minutes to get forwarded to me.
Okay.
Okay. So, but if everything you want to go over you can verbalize, that's probably the easier way to do it.
Okay. So this one says sine delta equals 15 over 17. Delta lies in quadrant 2. And then there's sine 2 delta, cosine 2 delta, and tangent 2 delta. Or, yeah.
I'm using x because it doesn't matter.
Yeah.
In other words, x is an angle.
Yeah.
Delta is an angle also. So, when you get it, this is almost the quintessential trig question. If you were giving somebody a trig exam and you can only ask them one question, this would be very close to what it would be. What's the first step?
15. I couldn't tell you.
Draw a triangle. That's whenever you think about what is the first step, draw a right triangle and label X. Okay? That usually the question goes like this. The sine of X is 15 over 17. X is in the second quadrant. Tell me the other 5 trig functions. Okay? That's the most basic trig question. Now, if we can figure out the other 5 trig functions, then we're going to be able to figure out the sine of 2x, the cosine of 2x, and the tangent of 2x. But this first step of drawing a triangle and labeling the angle is critical. Now, look at that triangle, and which 2 sides can you dimension?
The ones by the ones that connect the 90-degree angle.
Okay, that's opposite. In other words, there is a side that is opposite angle X. What is its dimension?
It's 15.
Okay. Where's the 17 go?
The hypotenuse.
Okay. Now you've got 2 sides of a right triangle. You can figure out the third side. What's
right.
the third side?
It's 17 squared minus 15 squared.
Okay, go ahead and do that on your calculator. I think that's 8. This is one of your basic Pythagorean triangles. Do you have a calculator in front of you?
Yeah.
Go ahead and do 17 squared minus 15 squared. Should be 64.
Yeah, I got 64.
Okay. So now we have all 3 sides dimensioned. That's critical. Because what that allows us to do is figure out all 6 trig functions. Okay, what's cosine of X? Here, I'm trying to figure out where to write. Yeah, let's write.
It's 8.
What is it?
8 over 17.
Is it plus or minus?
Quadrant 2. Minus?
Correct.
Yeah.
Don't forget, all students take calculus. That tells you the plus or minus sign on any trig function based on its quadrant. Okay, in the second quadrant, only sine is positive or cosecant. Everything else is negative. With me?
Yeah.
Okay. Now, what's the identity for the sine of 2x? Double angle formula for sine.
Wait, sine of 2x.
Yeah, because that's what they're asking about. They didn't really ask us what the cosine of x was. They want to know the sine of 2x, the cosine of 2x, and the tangent of 2x. Now you'll find out why I figured out what the cosine is here in a second. But you need to know the double angle identity for sine. 2 sine of x, cosine of x. With me?
Yeah.
Well, we know what the sine of x is. We know what the cosine of x is now. So that's pretty easy. That's 2 times 15/17 times a negative 8/17. Got it? I don't want to go on until I make sure you know, you understand what I'm saying.
No, I understand.
Okay. So we've got sine of 2x. I'm going to erase that just because I need the room. What's the identity for cosine of 2x? There's actually 3 of them. You can use any of them. These are harder to memorize than your basic 11, but clearly they want you to know them. So you're going to have to memorize these double angle formulas. There's 3 of them. There's cosine squared x minus sine squared x. That's the only one we need. So I don't need the other 2. This will work just fine. So what's the cosine of 2x going to be equal to?
Cosine of 2x is 15, or yeah, wait, no, sorry.
Just fill it in before you do any simplification. Always just fill it in. In other words, what's cosine of x?
Cosine of x is 8 over 17. Negative 8 over 17.
Negative 8 over 17. I'm going to put that in parentheses and square it. That's what cosine squared of x is. What's sine squared of x?
Sine squared of x is 15 over 17 squared.
Simplify that, you got your answer. Now, I can take these problems to the finish if you need me to, but at this point, it's just arithmetic and it's probably just a calculator. With me?
Yeah.
So what I'm asking you, I guess, is do you want me to give you a number for that, or do you want me to have you get a number for that, or are you good with that answer and going to the next?
I basically just plugged that into my calculator.
Well, okay. Yes and no. Your calculator is going to give you a decimal answer. You don't really want a decimal answer. What you have is 64 over, what is this, 269, I think, is 17 squared, minus 225 5 over 269. So what's that equal to? 161 negative over 269. In other words, your calculator is going to have a hard time coming up with that answer. Because it's going to convert everything to decimal. And who knows what that is? That's probably an irrational number. So I don't want to convert it to decimal. I want to leave it as a fraction. That's the most exact answer. So that's what the cosine of 2x is equal to. And your calculator would give you a decimal. So, yeah. I'm not as fond as decimals. You got to understand that decimals are always, not always, but they're always approximations if you're dealing with an irrational number. And it doesn't look like I can simplify 161 over 269. I know the bottom is not divisible by 3 because the digits do not add up to 9, or excuse me, it's not divisible by 9, and the top is not divisible by 9. The digits do not add up to 9. And the top isn't divisible by 8, or excuse me, 3, and the bottom is not divisible by 3 because the digits have to add up to a number that is divisible by 3. So if this thing isn't divisible by 9 and it's not divisible by 3, it's probably simplified. Might find something like 17 that goes into it, but unlikely. So that's your best answer. Now I don't know your teacher, whether he wants decimal answers, whether he wants exact answers.
He wants exact.
He wants exact, and he wants this. If he does not say round off to the nearest whatever, 2 decimal places or 3 decimal places, then he wants exact. Okay, so we figured out cosine. There's one other identity we're going to need. What's tangent 2x? We did this one the other day.
2 tangent delta over 1 minus tangent squared delta.
Actually, we didn't. We did the tangent of sum and difference. But one way to look at this, so you can always remember it, is it's the tangent of x plus x. And that, if you remember the sum and difference formula for tangent, then you will always know the identity for tangent of double angle formula. Because it's the same. If you, like I said, if I make this tangent of x plus x, then it's tan x plus tan x all over 1 minus tan x times tan x. Now, we didn't figure out the tangent. We need the tangent of x. Well, let's figure out that. From our rectangle, excuse me, from our triangle that we drew, what's the tangent of x?
15 over 8.
Plus or minus?
Minus.
Okay. That's all you need. That means this becomes 2 times minus 15 over 8, all divided by 1 minus 15 over 8 squared. And that's always the way to do it, and then simplify. When you're dealing with stuff like this, do not do any math in your head. It just increases the chance that you're going to make a mistake. In other words, it's easy enough to make a mistake even the way I've done it. But we'll eventually get this. That's just algebra or calculator problem. That's all it is. So it's easy enough to come up with that number. Okay? The key thing here is, here, let me make this a little bit more standard. The standard question would be, they tell you the sine is a certain ratio and the x is in the second quadrant. And then their question is, okay, what is the cosine of x, the tangent of x, the secant of x, the cosecant of x, and the cotangent of x? That is the quintessential problem. And that's where you just draw a triangle and label it. And then once you've labeled all three sides, you can get all 6 trig functions. They made it a little bit more complicated by asking you about the cosine of 2x, which is just a function of the sine and the cosine, and then the tangent of 2x, which is just a function of tangent of x, which you can get from this triangle. All right, what else?
Let's do. So tangent x equals 4/3. Comma 180 is less than x, which is less than 270.
So that tells you which quadrant it's in. Which quadrant is this?
Third.
What's their question?
Oh, and then you have A, B, and C, which is sine x/2, cosine x/2, and tangent over x/2. And then it's find the exact value of each of the following.
And those are sine of x/2, cosine x/2, and tangent x/2?
Yeah.
Okay. What's the first thing we're going to do?
Draw a triangle.
And not just draw a right triangle, we got to do something very important also.
Label it.
Label the angle we're talking about. Because I could make x the upper angle or I could make x the lower angle. I usually make it my lower angle, but it matters. If I make x the upper angle, then it changes the whole dimensions of this thing. Now, what can I dimension on this triangle?
So the opposite and the adjacent.
Okay, what's the opposite?
The opposite is 4, and the adjacent is 3.
Now finish it. Tell me the third side.
What was it? Hold on.
Tell it to me without using the Pythagorean theorem. What kind of triangle is it? Yeah, it's a 3, 4, 5 triangle. You're going to run into a lot of those. And when you recognize them, it's much easier to just put 5 in it than it is to go through all the math of the Pythagorean theorem. Okay, so now we have the triangle, so we can figure out all of the functions that we need. First of all, what's the identity for sine of x/2?
Sine would be so 4/5.
Hold on, we're not doing sine yet. We're gonna find out what the identity for sine of x/2 is. In other words, we can't do sine of x/2 yet. We can do sine of x, that's 4/5. But we don't know what sine of x/2 is. So we need that identity. What's the half angle identity?
Plus or minus 1 minus cosine over 2.
So what do we really need?
Cosine.
Yeah. So what's the cosine of x?
3 over 5.
What is its plus or minus sign?
Minus? I'm trying to think of what you told me.
Yep, all students take calculus, so third quadrant is a T, meaning only tangent and cotangent. Okay, so we know what the cosine is. The only thing we have to know is what the cosine is. So it's plus or minus, we'll get to that in a moment, 1 minus a minus 3/5, don't drop negative signs, ever. So what is that? What's 1 minus a minus 3/5?
It's 8/5.
Okay, divided by 2 is?
4/5.
Okay, so it's plus or minus the square root of 4/5. Are we going to use the plus or the minus?
Well, it's sine, so the minus.
But it's not sine, it's sine of x divided by 2. And x is in the third quadrant. So if you divide that by 2, where are you?
Oh, you're in the second quadrant?
Yes. So we know that the plus, that has to be plus. If x is a third quadrant angle, then the sine of x divided by 2 has to be a second quadrant angle, which makes it plus. So we use this plus right there, not the minus, okay? This plus or minus means you use whichever one you know to be correct. So the answer to this problem is square root of 4/5. Now, is your teacher going to accept that? That's basically 2 over the square root of 5.
Yeah.
You'll take that even though you have an irrational denominator?
Yeah.
Good. That's the way it should be. You shouldn't have to rationalize it. So we did the sine of x over 2. And the first thing we discovered is that what we really need is the cosine of x, right? To figure out what the sine of x over 2 is, it had nothing to do with the sine of x. It was all based on the cosine of x. What's the cosine of x equal to? What's the cosine of x over 2 equal to?
It's 1 plus cosine x over 2.
Which is equal to plus or minus 1 minus 3/5 over 2, which is what?
1 minus 3. Oh, 2/5 over 2.
Okay, so that's 1/5. Square root of 1/5. Are we going to use the plus or the minus? We're doing the cosine of x over 2. We know that that x over 2 has to be which quadrant?
The fourth.
No. If x is in the third, because it's between 180 and 270, divide everything by 2. I can divide all three of those pieces of that inequality by 2. So then I get x is between 90 and 135. Which quadrant is that?
That's the second.
Cosine is negative in the second.
Yeah.
There's your answer. And finally, the tangent of 2x. What's the identity for that?
There's a lot. 1 minus
There's
cosine.
only one for tangent. There's a lot for cosine. Oh no, excuse me, I'm mixing it up with the cosine of the double angle. Tangent, remember one thing about tangent. It's sine over cosine.
Yeah. So 1
it's
minus
gonna look,
cosine.
yeah, it's going to look a lot like the previous two look. What is it?
1 minus cosine x over sine x.
I don't think so. I think it's over 1 plus cosine x. Let me look it up.
That's what it says in my book.
Yeah, no, I believe you. I just don't remember it being that. Hold on. Yeah, I gotta go backwards, not forwards. Sorry. Wow. Okay, hold on. I think I got it. Boy, it'd be nice if they gave you a nice little table. You have it in your book, the tangent of x over 2?
Yes, that's what I'm reading right now.
And it says what?
Well, it goes tangent x over 2 equals plus or minus square root of 1 minus cosine x over 1 plus cosine x equals 1 minus cosine x over sine x, which equals sine x over 1 plus cosine x.
That's what I thought it was. Right? Is that correct?
Yeah.
Okay. So, again, the only thing we don't need the tangent of x, we just need the cosine of x. In other words, all three of these questions depended only on knowing the cosine of x, which we know. Cosine of x is negative 3/5. So it's plus or minus 1 minus 3/5 over 1 plus 3/5. We going to take the plus or the minus? Which quadrant is x over 2 in?
The second.
And tangent is what in the second? Positive.
Negative.
Negative. So we're going to take the negative. So what is that? Negative square root of 2/5 over 8/5. So negative 1/2. 2/5 over 8/5 is 1/4. And square root of 1/4 is 1/2. So negative 1/2 is the answer for the tangent of x over 2. The key thing to take away from this is that we didn't need to know the sine, the cosine, or the tangent. Yeah, we needed to know the cosine of x, but that's it. All three of these half-angle identities are based on the cosine. And of course, we needed to figure out where x over 2, what quadrant it was in. They told us which quadrant x was in, but x over 2, you got to divide all three sides by 2. Middle, and the left and the right side. All right. What else you got? Go.
Let's do 2 sine 15 degrees, cosine 15 degrees. And then it says, write each expression as the sine, cosine, or tangent of a double angle and find the exact value of the expression.
Okay. Tell me what this is equal to. What's the identity?
2 sine x cosine x.
Does that look familiar with this?
Yeah.
So what is that we're looking at?
Sine 215.
So that's the sine of 30 degrees.
Okay.
What's the sine of 30 degrees equal to?
Shit. I forgot. It's
1/2.
pi over.
No, that's the one you want to remember more than any other. Because it's easy. Sine of 30 is 1/2. Cosine of 60 is also 1/2. Okay? So what they're really asking you to do here is to know your double angle formula backwards. In other words, you have to recognize that what you're looking at is 2 sine of x cosine of x, which is equal to the sine of 2x. So again, all of these are directed on getting you to memorize your trig identities. Double angle, your half angle. What else?
Let's do, it's the same exact concept. Cosine squared 75 degrees minus sine squared 75 degrees.
Which identity does that look like?
Ugh. I want to say I can say it, but I can't.
That's the double angle identity. Now, the double angle identity actually has 3 identities. And I always get the other 2 mixed up. One of them is this, and the other one is this. But there's the 3 identities, okay? But they didn't give us these 2. They gave us this one. So what is this? The cosine of what?
Cosine of 75?
No,
Or it
that's
would be
75.
50.
So what's cosine of 150 degrees?
I don't know.
Okay. We should work on this because this is one of the things they want you to know is your unit circle. Okay, let me just go through this briefly. Which quadrant is 150 in?
Second.
That's the formula for second quadrant. How to convert it to a first quadrant. So what is the equivalent first quadrant angle?
30 degrees.
What's cosine of 30?
Cosine of 30. I don't know.
Root 3 over 2. That's the second one you want to remember the most. Remember that the sine of 30 is 1/2, and the cosine of 30 is root 3 over 2. Now, do I need a plus or a minus sign in front of that?
The minus.
Yeah, and that's the way I do every trig angle. I don't worry about the sign until the last step. What I want to get is the number, the absolute value of that number. And you always can get that by merely converting this to a first quadrant angle. Now, they may have taught it to you as that's the reflex angle, or the reference angle. That's the same as the first quadrant angle. When I say the equivalent first quadrant angle, that's what these formulas give you. If it's in the third quadrant, you use that one. If it's in the fourth quadrant, you use that one. So if I give you an angle of 315 degrees, what is its equivalent first quadrant angle?
315 would be 45.
If I give you an angle of 210, what is its equivalent first quadrant angle?
30 degrees.
And if I give you an angle of 135, what is its first quadrant equivalency?
45.
That's how you do it. You combine that with all students take calculus, and as all you have to remember is the first quadrant angles, 30, 45, and 60. If you can remember 30, 45, and 60, then you can answer the entire unit circle as long as you memorize that. And that's the way to do it. They act like they give you this big unit circle and they want you to memorize 16 points on that thing. That's not the way to do it. The way to memorize 16 things is to group it into groups. And that's what we're doing here. I've got 3 different groups. I got a second quadrant, a third quadrant, and a fourth quadrant. And then I got all students take calculus. That's 3 or 4 things that I have to memorize. That's it. And then I have to memorize what the sine and cosine are of 30, 45, and 60. Once I've done those 3 things, I can tell you any trig function for any angle in the unit circle that is a multiple of 30, 45, or 60. So you don't need to memorize 16 things. That's ridiculous that they even suggest it. What you have to memorize is 3 things, 4 things, and then 4 more things, all your first quadrant angles. So let's test you, because this I can't overrate the importance of this. First, tell me an equivalent first quadrant angle, which I'm going to always put in parentheses.
It would be 45.
What's the tangent of 45? It's another one you want to memorize. Yes, memorize that.
Oh,
All right, here, let me help.
I know the
All you
end
really
point
have to memorize is these 2 triangles, the ones you've been working with for 5 years. What are the dimensions on these triangles? On the 30-60, what's opposite the 30?
1,
What's opposite the 60?
2, and then square root of 3.
I got it quite a little bit backwards. 2 is the hypotenuse. Okay? So if you can memorize that, well, then you can clearly get the sine, cosine, tangent, any trig function you want of 30 or 60, right? And you can see why the sine of 30 is 1/2. And the cosine of 30 is √3/2. And the tangent of 45 is 1. Because this side is 1, this side is 1, and this side is √2. So to memorize your first quadrant trig functions, you really only have to memorize those 2 triangles. That gives you all your first quadrant trig functions right there on a silver platter. Okay?
Okay.
So tangent of 45 is what?
Tangent of 45 is 1.
Okay, and is it plus or minus? It's always the last thing.
Minus.
Which quadrant is 225 in? Remember, it's 225 we're looking at, not 45.
It's in the third.
What is tangent in the third? All students take calculus.
Positive.
There's your answer. Okay, let's do another one. Equivalent first quadrant angle.
30.
Sine of 30.
So opposite over hypotenuse. It's 1/2, half.
Plus or minus.
Minus.
That's how you do it. You can handle any angle, as long as it's a multiple of 30, 45, or 60. I could throw in secants and cosecants. It wouldn't matter. You'd still be able to do it if you knew those two triangles. Okay? All right. So now you know your unit circle, which is important. You can't really do trig unless you know your unit circle or know how to figure out each spot on the unit circle. Okay, so now let's get back to some of the problems you have.
Let's see. Those are verifying identities.
I tell you what, before we go on, let's talk about one other thing. Let's talk about negative angles. What's the sine of minus 30 degrees?
I don't know how to do negative angles. Honestly, if I'm going to be honest, my professor is one of the worst professors, and I haven't understood.
You don't need to make any excuses at all. It's just that trig has to be learned in a certain way, and you really have to learn your unit circle. Okay, so if I occasionally am backing up, it's because you've got to know this stuff before you can really go forward. Okay, so let's do it two different ways. I'm going to show you the regular way to do it, and then I'm going to show you an easier way to do it. What is the equivalent first quadrant angle? Or, excuse me, what is the equivalent coterminal angle? What is the sine of minus 30 actually the same as?
It's the sine of 330.
Yeah, that's coterminal, right? In other words, coterminal means multiple of 360. If I take a multiple of 360 and add it to negative 30, I get 330. So it's definitely the same as the sine of 330. Now, if we go through our normal process, what's the equivalent first quadrant angle to
that? 30.
What's the sine of 30?
Half.
Which quadrant are we in? So what's the plus or minus sign?
We're in the fourth, so negative.
Okay. That's the hard way to do it. The easy way to do it is to realize that the sine of negative x is the same as negative sine of x. Because it's an odd function. It's not even. It's odd. Sine and tangent are both odd. So both of them follow this rule. Cosine is even. Cosine does not follow this rule. Cosine of negative x is the same as the cosine of x. So if I follow that rule, I go straight from the sine of negative 30 to what?
To 30.
To negative sine of 30.
Or negative sine of 30.
And we know sine of 30 is 1/2, so we have our answer in one step here. I don't have to go through this nonsense of figuring out that it's a 330 degree angle, and that's the equivalent of a 30 degree angle, and then it's in the fourth quadrant, so I put a negative on it. I can skip all of that second step, as long as I remember the odd, even properties of those three trig functions. And they really do speed it up a lot. It seems like I've only skipped one step, but this is always the way to do it. Okay, I'll give you another one. So using that odd even property, what is that?
165.
No. The sine of
Wait, hold
negative
on,
x
sorry.
is equal to what?
225.
No, it's the negative sine of 135.
Okay.
In other words, this is negative x. What I'm saying is it's equal to negative sine of x. Now, figuring out this is much easier. Still have to go through the normal process. What's the equivalent first quadrant angle?
It is, hold on, let me do the math.
180 minus theta.
You have me lost. I'm like trying to do it, but
That's okay. When I have an angle that is not in the first quadrant, and it is not negative, which is what I have, a 135-degree angle, my first step is to turn it into a first quadrant equivalent. And that's where I use the 180 minus theta, or if it's in the third, it's theta minus 180. If it's in the fourth, it's 360. Okay, so 45. What's the sine of 45?
oh, we just did this shit. It's it's 1 over square root of 2.
Okay. Now, we're talking about 135. Is that, which quadrant is that in?
The second.
So what is the sine in the second?
Negative.
No, it's positive.
Or,
All students read calculus, okay? So this part is 1 over root 2. But I still have this negative sign out there. So I have to apply that. That doesn't go away. So that's your answer. And if you think about it, that's a third quadrant, right?
Yeah.
And if I were to graph that, it's 90. In other words, that angle is 135 degrees. Because I'm going clockwise, it's negative. But it still puts it in the second or the third quadrant. So I know the sign has to be a negative number. And it turns out to be a negative number. So we're copacetic. If we'd have gotten a positive number over here, we'd have known we made a mistake somewhere. All right. I've covered negative numbers. I've covered all multiples in all 4 quadrants. What other kind of problems do you got?
Let's see. We can do. So we got to use the power reducing formulas to rewrite each expression. So 6 sine to the 4th x.
Okay. The power reduction formulas go like this. And this is only valuable for calculus. It's the only time you really need it. Okay, but when you do get to calculus, you really need it. So sine squared of x is equal to, you think about this for a second. Let's see, it is the square root of 1 minus cosine 2 theta over 2, I believe. Let me just check that. Well, finally, I see my tangent half angle. Oh, I do see what you were seeing. 1 minus cosine of alpha over sine of alpha. That's different. I've never seen that one. It's interesting. Here we go. All right. There's no radical sign, so I got that wrong. And it is a minus sign. So the rest of it's right. So if this is an identity, what is 6 sine to the 4th of x equal to?
Isn't it 6 and then 1 minus cosine 2 delta over 2 squared?
Yeah, precisely. Now, I don't know if they want you to simplify that further or not, do they? Do you have answers on these by chance?
Yeah.
Why don't you go ahead and look up the answer and let's see if they want us to simplify it, because that's really the only way to know. They probably do, the more I think about it. So square that. What do you get when you square?
Let's see, so that's...
What do you get when you square the numerator?
It says, yeah, the answer to that one was 9 over 4 minus 3 cosine 2x plus 3/4 cosine 4x.
Okay, so let's go ahead and do it. Square that numerator for me.
It's 1 minus cosine squared 4.
Oh, it's
Or 2.
1 minus 2 cosine of 2 theta plus cosine squared of 2 theta. In other words, when you are squaring a minus b, doesn't matter whether it's algebra, polynomials, or trig functions. It's a squared minus 2ab plus b squared. That's what I did to get that. 2 times 1 times cosine of 2 theta is that part. 1 squared is 1. And the last part is plus cosine squared of 2 theta. And what's the denominator?
4.
Okay. So now we can do a little simplification. Let's see. I guess I can distribute the 6. We'll make that a 6. We'll make that a 12. We'll put a 6 there. Get rid of the 6 over there. Now, I can simplify this a little bit. Can you read it well enough?
So, explain that last process again.
Okay, I had my original 6 out here.
Right.
Here, let me rewrite it all. Now, I'm going to square what's inside the parentheses, which means squaring the numerator and squaring the denominator. Numerator squares like this. The denominator becomes that. You with me?
Yeah.
Now I'm going to distribute. I'm going to multiply the numerator by 6. I still have a 4 in the denominator. Now I can simplify. I can do a couple of things. I can split it into 3 fractions like this. It's 1 fraction minus that fraction plus that fraction. Okay?
Okay.
And what that gives me is 3 halves, that's 6 over 4, minus 3 cosine of 2 theta, plus 3 halves of cosine squared of 2 theta. Now, I realize that that doesn't agree 100% with your answer that you have.
Uh-huh.
Nonetheless, it's correct. It's just they have done more stuff to it. I'm not sure where they got the cosine of 4 theta. When you square the cosine of 2 theta, you do not get cosine of 4 theta. What you get is cosine squared of 2 theta. So I'm quite certain that that is the answer. If I put it into Wolfram alpha, I think I will see this. It's probably also exactly the same thing as what you read. It's just a trig identity. Well, what was the answer you gave me?
It's so for 35, it said 9/4 minus 3 cosine 2x plus 3/4 cosine cosine 4x.
Like that?
Yeah. I think they just left the 4.
Well, I'm not quite sure what happened. They got the middle term the same, but the two end terms are different. Now, they're also using the cosine of 4x, whereas I've got the cosine squared of 2 theta. So I could apply the double angle identity again for cosine of 2 theta and end up getting something that says cosine of 4 theta. But it's also possible I made a math error, or this is 1 plus instead of 1 minus. There's all kinds of things that could explain the discrepancy here. But this is definitely the way to go about doing it. I mean, in trig, you should realize by now that you can come up with a lot of different answers that are the same. In other words, a lot of trig identities look completely different than their identity. So it's not impossible at all that this is the same answer as this over here. It's just I don't want to spend 20 minutes proving it. And it's also possible that I made a math error somewhere along the line, although I don't see it. But the key step here is to separate that into sine squared x times sine squared x. Okay. Because we know what that is. That's 1 minus cosine 2 theta over 2. You know what that is. So this has to be correct, assuming sine squared is 1 minus cosine 2 theta. It is. I'm looking at it right in the book. Over 2. So this is correct. Pretty sure this is correct. Pretty sure that's correct. I'm pretty sure that's correct.
Huh. And I don't know why the book has it like that.
Well, there's a lot of explanations as to why it could be like that. They may have done something with this cosine 2 theta. In other words, they could apply a trig identity. Cosine of 2 theta is equal to cosine squared of 2 theta minus sine squared of 2 theta. And you could work all around that and end up getting to this. I don't know. I don't know how they got that, to be honest. And at some point, we don't want to spend our whole session. Actually, it's over, so we're done. But
do you have any like websites that could help me, I don't know, understand the trig identities better? Or just that have the list?
You just have to memorize them, Nico. That's the only thing I can give you. I have them memorized because I tutor so much trig that I just do. I memorize them, and I don't even have them all memorized. I know you know your first 11, right? You know your six reciprocal, your 3 Pythagorean, and your 2 quotient ones. You know those?
Right.
Okay.
Yes.
So the other ones are the sum and difference. You know that one.
Mm-hmm.
You know this one. And you know this one. So you have to know those. And the only other ones you really have to know are the sine of 2x, the cosine of 2x, and the tangent of 2x, and the sine of 1/2 x, and the cosine of 1/2 x, and the tangent of 1/2 x. Memorize everything you see on the page and you'll have them all memorized. You don't actually need to memorize this power reduction formula. Why? I'll show you why. Cosine of 2x is equal to 1 minus 2 sine squared of x. It's also equal to 2 cosine squared x minus 1. Okay? So from that, you can solve for sine squared of x. You don't need to memorize it. Just solve it algebraically. It's going to be the square root of 1 minus cosine 2x over 2. Same thing for this. If you want to know what the reduction formula is for cosine squared of x, just solve this equation. So you don't need to memorize those. You do need to memorize these. And of course, all 3 of those. And it's just memorization. I don't know that I have any secret to it. Just need to memorize them. And then it's just a question of applying them whenever appropriate.
Okay.
Okay?
Sounds good.
Nico, I will let you go this evening. You have a good rest of your evening. We'll talk
well, David.
next time.
Sounds good.
Bye-bye.
Bye.